नहीं है मतलब ऐसे उसके की था वाईफाई की था
Hello everyone, welcome to one more live session on our channel. Today our topic of discussion is robotics and automation in electronics industry. Again, I welcome Ashwini Kumar Sinha ji and Suresh Dwivedi ji for this discussion. So my first question is, what is the role of robotics in electronics manufacturing industry?
So nowadays, robotics are used in many ways in the electronic industries. So one of the common use of the robotics is in you might have seen the smart in the PCBA, the PCB assembly unit where we can use the pick and place robot to pick and place the PCB from the conveyor belt to the packaging system. The second one is the pick and place of the SMT devices, SMT, discrete components or ICs to the PCB precisely, and then again the same kind of those robotics can be also used in a smart soldering, the robotics based soldering, PCB soldering as well. Apart from this PCB manufacturing, there are lots of robots now with the probes. Smart probes are used in the industry to automate the whole testing system of the PCB, of the electronic circuit or PCB, whatever it is there. And then second is the you might have seen various testing video of phone, a smartphone, and all those things. So if we do those testing things manually by a human, like each and everything, camera button and all those things, if those things are been test, all those gadgets and devices, electronic devices, are being tested by humans one by one, then it will take a lots of time, a lots of work power, man hours, and it will takes lots of oh, money as well to to pay for to the workers, and for the workers as well, that it's take lots of time to test everything, or the UI of on the gadgets or the functionality of the gadgets one by one. It's very time taking. So in those area we also use, currently we are start using the robots, where the robots do testing of the touch screens, the other functionality automatically. So now robotics are taking over the human, and now the robotics are becoming more intelligent with the AI, smart visions, camera, and the machine learning models and cobots. So there are different areas in which we are currently using, and we are currently developing the robots to be used in the electronic industry, in the PCB, from the PCB assembly to the testing of the PCB to the testing of the complete gadgets and all those things.
Okay, so how do automated systems improve efficiency
Actually, automated systems significantly enhance efficiency in
electronic
electronic production by streamlining process, reducing human error, and the increasing throughout the key. The key ways that improve the efficiency, such as the speed and the precision. Actually, automated machines can perform tasks such as assembly, soldering, and testing at a much faster rate and with the greater precision than the humans. This ensures consistent product quality and they reduce the likelihood of the defects. Another parameter is the 24 upon 7 operation. Since automation enables continuous operation without break, holiday, or shift, maximizing production time, this leads to increase the output over the time. And next is the cost reduction. By minimizing the labor cost, reducing waste, and optimizing resources use, automated system help lower overall production expenses. They can also reduce the need of the extensive manual labor in high risk or the repetitive tasks. Another, it also improve the quality control. Actually, automated Systems are equipped with the advanced sensors and software that can monitor every stage of the production, ensuring high quality and the compliance with the standard. Real-time data collection allows for the immediate corrections when necessary. Another parameter is the scalability. Actually, automated systems can easily be scaled up or adjusted to meet the demand fluctuations, making it easier for the manufacturing to the respond to market need quickly. Another is supply chain integration. Since automation can streamline intensity management, material handling, and scheduling, improving the flow of the material and the products across the production line. This integration can reduce delay and the bottleneck. By including these automation, electronics manufacturing can optimize their operation, enhance product consistency, and remain competitive in the fast-paced market. That's all. And next question is, hello?
Yeah. So,
Next question.
yeah. So, what's the main difference between the industrial robot and the cobots?
Just repeat the question again.
Yeah. So, what is the main difference between the industrial robots and the collaborative robots, the cobots? Yeah, so let me first answer, give a little bit of idea regarding this from my side, and then you can uh, add along with me. So the industrial robots or the robotic hands that we might using the fully automated robots, can be worked without need of the any human beings, and they can work in very independently and operate in very isolated environment as well. And while the collaborative robots, they work along with the human beings. Like me, I can work along with these collaborative robot cobots. That's why we call it cobots. So they work along with us in a collaboration with us. Like suppose that I am doing soldering, some kind of soldering, or I am doing some kind of picking and placing thing. So if I were to do one pick and place from this to this, I can use my hand like this to this, or use the soldering. Then the what the other cobots are can be programmed that they can mimic what I am doing, how I am moving the hand. So instead of needing 4 to 5 more or 4 to 5 or 100 of more as this one man who's doing this pick and place thing or soldering job, whatever the things, more 100 number of other people are also required to do that job. What we can program the cobots to just mimic my hand and mimic my movement. They can capture my movement, and they can move along with me, the other different robots. So instead of putting 100 of men to do the same kind of job, we can implement one human being, and then attach hundreds of cobots along with me, and that can mimic what I am doing, and they can work in the collaboration of me. So in this way, all the other 100 of process can be fast, can be made fast, and can be made efficient, because we don't need more 100 Ashwini Kumar Sinha to do that soldering job, or do that kind of particular job, because they instead of adding more 100 Ashwini Kumar Sinha, more 100 living being, more 100 staffs to do that soldering, the 100 robots can collaborate with me, and they can mimic my what I am currently doing. So this is the main difference between the collaborative robot and industrial robot, fully automated industrial robot. Automated industrial robot are very highly complex program and can be added with the machine learning, AI, and computer vision to do everything independently without need of any human guidance. While the collaborative robot can need must need they need a human guidance, and they follow the human instruction. They need a human instruction to work along with the human. So this is the main difference between the industrial robot and the cobot. So, Suresh sir, if you have any more thought on this, then you can also say what are the other use of the cobots in the industry or any kind of automotive robot, and what are the main difference between those? I have
Actually, when we are talking about the concept of pick and place robot and how it works, we can say that pick up and place robot is a type of automated robotic system used in the electronics assembly to efficiency pick up the components and place them into the circuit board or other assembly fixtures. The robot's primary function is to handle the position parts with the high precision and the speed. Main components which used in the pick and place robot is the gripper or vacuum tool. The robot uses gripper suction cup or vacuum tools to pick up the components. The gripper is designed to handle the different shapes, size, and the weight of the electronics component like resistors, capacitors, chips, and the connectors. Another key component for the pick and place robot is the vision system. A camera system is often integrated to provide real-time feedback. It helps the robot locate components, verify the position, and align them accurately with the circuit board. The vision system can also detect if the components are misplaced or missing. Another key component is the robot arm. It is also very important. Robot arm, usually equipped with the multiple degrees of the freedom, moves and the components from one place to another. It is programmed to follow a specific path for the precise placement onto the board. Now the question arises how pick and place robot works. Actually, components retrievals pick and place robot first identifies and retrieves component from the feeder or tray. The vision system helps guide to arm the right components, ensuring the proper gap. Another parameter is the placement. After picking up the component, the robot moves it over to the designated position on the PCB, which is normally known as printed circuit board. The placement is done with the high precision to ensure proper alignment for the soldering or further processing. And another is the placement. When we are talking about the working of the pick and up robot, the repetition is also very important. The robot performs this task continuously and in rapid succession, significantly reduce cycle time compared to the manual assembly. So this system can work on the multiple board simultaneously if necessary. Now the question arises, what are the benefits of the pick and up robots in the electronics assembly? So there are various benefits such as the speed and efficiency. When you are using pick and up place robot can perform high speed operation with the consistent accuracy, speeding up the overall assembly process. Another benefit is precision. These robots ensures components are placed accurately, reducing the likelihood of errors or defect in the final product. Another benefit of using the robot is flexibility. The robot can be reprogrammed or adjusted to handle different types of the components of the layout, making them adaptable to the various products. And the next benefit of using the robot is reduced labor by automating the handling and the placement of the components. Those robots reduce the need of the manual labor, which can be time consuming and the error prone. In the brief, you can say pick and place robots play a crucial role in the modern electronics manufacturing, helping to increase production speed, improve quality, and the reduce operational cost. These are the benefits of the pick and up the robot.
Okay. Okay, so what is the significance of machine vision in robotic automation and electronics industry?
Yeah, so the machine vision is very important if you want to make any kind of automated system in the robotics, or implement any kind of robotics, because whatever the robots, the task it is doing, either it is detecting, either it is doing the automated soldering, or it is doing some kind of building as well. Some, there are very industrial robot that do can electronic welding, or it is doing the assembly, or it is detecting some kind of, what's a defective products from the conveyor belt. So everywhere the machine vision is used. So these machine vision, combined with the camera and the AI models are implemented, and they are trained to detect the faults. Like suppose that we are making a system, industrial system, where we need to pick out the defective or cracked devices or cracked cases in the for the for particular gadgets, before packing. So if we implement the machine vision and the AI, then using the camera, it can, and the pre-trained ML model running inside that camera, they can take the video or picture in the real time, that the whatever the case or whatever the things going on the conveyor belt, and they can analyze it, and they can find out the defects and cracks on those things, and automatically pick out and uh, into the defective container, and automatically sort them out. And such machine vision can be also be now be being used in the PCB inspection as well. So they take the picture in the real time, either thermal image, or the infrared image, or the real image, and using the machine learning model running inside that thing, the whole computer vision thing going inside that camera, and the processor, it can detect the defect in the PCB, cracks in the PCB, or some defects in the PCB, using the image, or any thermal defect or thermal analysis using the image, and they can sort them between the defective PCB and the real PCB. And this image processing and computer vision also be implemented in the SMT, to identifying the particular SMT components, and placing on the PCB at the right, and then again inspecting it out whether that component is placed in correct manner or not. So that can be also be implemented in such a way as well. And then for the soldering, the same thing, computer vision helps them into identifying the SMT objects, the PCB area, and all those things, analyzing the whole PCB size and everything, and soldering at very right amount, at very right temperature, everything, using the thermal camera and the computer vision. So they combine with each other, and these machine vision are combined along with these robotics arms, or robotics things, to automate things, fully automate the things out. So these machine vision is very one of the, you can say, if you are making very automated robots, if you are very automated system in the industry, either in the PCB manufacturing, or in the assembly line, or anywhere else, computer vision is the important part of it, because they are one who is seeing the things out, who was seeing the things out, and extracting out the information from what they see, what the image is being captured, extracting out the features and image, and then analyzing them, and make a decision based on the image that is being analyzed, or that is being processed. So image processing and computer vision, one of the, I can say, it is one of the important part for the robotics based automation, because they are the main things. They are the things that are being actually done. They are the initial data set that helps in the robots to decide whether to do this thing or that thing.
Okay, so what safety measures are typically implemented in automated system used in electronic manufacturing?
When we are talking
So
about the safety measure, so safety measures is in automated system used in electronics manufacturing are critical to protect both the machines as well as the worker. These measures help prevent accidents, minimizing risks, and ensure a safe working environment. For example, when we are talking about the safety guard and the barriers, actually physical barriers first and the protective fencing are barriers are often placed around the automated machinery to keep the worker at a safe distance from the moving parts, robotic arms, and the other hazardous components. Another is safety doors. Doors with the interlocking system that prevent machines from the operating when the door is open. This helps protect workers from the accident contact with the moving machinery. Another safety parameter is the emergency stop button. Emergency shutdown is very important in case automated systems are equipped with the easily accessible emergency stop buttons that immediately halt the operation of the machinery in case of an emergency, preventing the further damage or the engineering. Another parameter for the safety parameter is the safety sensors and light curtains are also used in here. Such as when we are talking about the sensor, the proximity sensors are used in the systems. So these sensors detect the presence of the object or the people near the machinery and can trigger automated pause or shut off to prevent the accident. In some machinery, light curtains are used. So these are the optical sensors that create an invisible barrier. If the barrier is broken by any person, by any machinery, by any other things, then it also protects from any accident. Another is the safety parameter is lockout or tag out, low toe procedure. Lockout systems, automated systems are equipped with the lockout machine mechanism that prevents machines from the being turned on while they are being being served or the repaired. And tag out is tags are used to indicate the machine is under maintenance or should not be operated. Another safety parameter is the training and the safety protocols. Operating training, workers are trained to operate automated system safely, including how to recognize hazards, follow proper procedures, and use safety features. And safety signals, clear and visual safety instructions are posted on the machine and in the work environment to remind operators of the potential risk and proper safety practices. Another safety is the collaborative robot, normally known as cobots safety. For force limited robots, cobots are designed to work alongside human safety. They are equipped with the sensors that limit the force they can exert, reducing the risk of the injury in case of the accident contact. Soft material and the rounded edge. Cobots often have soft or rounded edge to minimize injury risk during the interaction with the human workers. Next parameter is the safety parameter is the machine monitoring and diagnostic. It is based on the real-time monitoring. Many automated systems include sensors that constantly monitor machine status, detecting them potential malfunction or safety issues before become the hazardous. Next may be proactive maintenance. Advanced system can predict potential failure and schedule maintenance before problem arise, preventing unsafe condition. Next safety is the fire safety. The fire suppression systems is also used in the robot, which are equipped with the fire detection and suppression mechanism such as sprinklers or CO2 system to mitigate risk associated with the electrical components or the overheating. Another safety parameters are the regular inspection and maintenance. When you are in routine checkup, then automated system undergo regular inspection to ensure all safety mechanisms such as emergency stop and sensors are functioning correctly or not. Preventing maintenance, schedules maintenance minimize the risk of the system failure, ensuring that the safety sensors remain in a good working order. So when you are using these safety parameters, so you can say electronics manufacturing can create a secure and efficient working environment that protects both the workforce as well as the machinery. That's all.
Okay, so um, okay, so what are the main challenges in integrating robotics into existing product line in electronics industry?
So there are lots of challenges there as well in integrating the robotics into the existing the production line in electronics industry. Robots can't do everything like us. In some way, somehow, it's our structure, the human being structure, the human being mind, the analysis capability of the human being still is better than the robotics in some part. And suppose that there are areas where you need to, you need to precisely do the soldering or precisely do the, building of particular things. And during those soldering and welding, you need to maintain particular temperature, particular condition, and you need to find out every single details of that thing while maintaining the whole system. Then in such cases scenario, many times the robotics fails, and there are some areas where the robotics hand, these robotic system or mechanical system, whatever we made, can't reach those areas. Like suppose that I have to do the soldering and welding inside some, inside or do some electronic connection inside some complex area where the robots, we can't put the robot hand inside that. It's only be done by the human beings. Is there a very lots of areas and in aircraft, assembly line, or in submarine assembly lines, or you can even in the automobile that are being still being done by the human beings, because those robot hands, those complex mechanical parts can't reach. Our hand are more degree of, like if you compare the degree of freedom of our hand to the robotic hand or any kind of mechanical structure, then our degree of freedom is greater than those robotics, because we can move our hand in this direction, this direction, and then this direction, and then turn it out. Like we have a lots of degree of freedom in all different directions. Those robotics hand can't achieve, and the accuracy of the movement of our hand and fingers that still didn't being achieved by the robotics. Even we have a lots of, we have done a lots of improvement in the various motors like the stepper motors or the servo motors, where you can do the precise, very precise precise action and movement, but still they are not that much accurate like humans, and they did still don't have that much of degree of freedom in those. So these are the challenges still there in the robotics, like achieving the degree of freedom like the human hand have, like achieving those achieving those analysis and observing capability that what we human have and there are various aspects of these things. If you list it out, there are lots of aspects of these things. So there are still a lots of challenges, but with the use of the AI and modern sensors, and with the more actuated motors and more advancement in the motors, now we are able to produce micro motors, macro actuators, that and MEMS technology that can do slight movement and smaller in the size, but using which we can achieve more degree of freedom, more using the generative AI we can achieve more intelligence than the human brain. But still there is a gap between that, and there are lots of challenges in implementing. So there are still a lots of areas in the industry where either we use the cobots that use the instruction with a human in the real time to do those things, or whole the things are being done by the human hand itself. There are lots of, you might have seen the productions or industrial videos out there. If you want to search on the internet, you can go and search there. Lots of things are still being done by the human beings, not by the robots. Like in the Rolls Royals, the painting thing is still being done by the human hand, because that precision can't be reached by the robot hand. The Royal Enfield assembly line and many big companies are still using the human, and they prefer the human touch to their production line, to their to their assembly line, because the robots can't achieve that.
Okay, so how does a PLC interact with robot in automated production environment?
Yeah,
Should I
just
repeat my
repeat the question
question?
again.
Okay, how does a PLC interact with robots in an automated production environment?
Actually, in an automated production environment, PLC, normally known as programmable logic controller, plays a crucial role in managing a controlling the operation of the robot, coordinating various processes and ensuring smooth and efficient production. You can consider use of the PLC as a first of the question arises why we use the PLC. First, it is used to control and coordinate the machine. PLC as a central controller. The PLC acts as the brain of the system, controlling and coordinating the robot and other equipment in the production line. It is responsible for the sending commands to the robot, receiving feedback, and adjusting the system operating in the real time. Another is the input and output. Normally, IO signals, input and the output signal. PLC communicate with the robot through the IO signal. It sends digital or analog signal to control robotic actions. For example, moving to the position, picking a component, and it receives the signal to monitor robot status, position, feedback, error alerts, etc. For example, output, when commands to robot, it is used for starting and stopping the movement. It is the initial task. Input, the feedback from the sensor are encoders on the robot for confirming that the task is completed or not completed. So this is known as the input. Another is the motion control. PLC are used for controlling sequential operation. PLC are used to sequence the robot action. For instance, it is an assembly line. The PLC controls the timing and order of the robot movement, such as picking up a part, moving it to another station, are placing it on a conveyor belt. So sequential operation is very essential parameter in the PLC. Another is the motion parameters. The PLC can also send motion parameters such as speed, direction, and position to the robot controller. In advanced applications, like the PLC may adjust these parameters in response to the real-time production needs are based on the sensor feedback. Another application of the PLC is the integration with the other equipment. It uses synchronization. PLC ensures that robots are synchronized with the other machinery in the production environment, such as the conveyors, sorting systems, or inspection equipment. For example, a robot might be instructed to pick a component from the conveyor at a specific time based on the signal from the PLC. Material handling. PLC can control material handling systems, directing robot to pick up components from the bins, load part onto the assembly line, or sort finished product based on the predefined criteria. Another use of the PLC are the safety and monitoring. When you are in case of emergency stopping, the PLC are integrated with the safety system to ensure that robots stop immediately when any emergency is taking place. The PLC monitors input and safety sensors, for example, light, curtains, emergency stop buttons, and send a signal to the robot to halt the operation if the safety breach is detected. Status of monitoring. PLC continually monitors the status of robot, for example, operational readiness, fault condition, and adjust production process as necessary. For example, if a robot counters an error, the PLC may stop the robot immediately, send an error message, and alert the operator. Another application of the PLC are the communication with robot controller. Robot controller is very important. So robots typically have their own dedicated controller. For example, industrial robot controller, motion controller that manage the specific movement and the action. PLC communicates with these controllers to send a high-level instruction and receive feedback. This communication may be done via the protocol like Ethernet IP, Modbus, or Profibus. Programmed logic. PLC execute a program sequence of the operation which might be include logic for when and how the robot should perform certain tasks. For example, it can detect a timing for the robot to perform the assembly task or to change the operation depending on the production cycles. Another application of the PLC is the data collection and feedback. Sensor integration. PLC collects the data from the sensor attached to the robot and other machinery. This data may include the information about the robot position, operational speed, temperature, or the load condition. The PLC can use this data to optimize operational and prevent potential malfunctioning. Real-time adjustment. Based on the feedback, PLC can adjust robot operation in real time. For example, if the robot is running ahead of the schedule, the PLC may slow down the operation of the other machines to maintain the synchronization. Another application of the PLCs is the human-machine interface, HMI. Operational interaction. The PLC often communicates with the human-machine interface that provides operator with the visual display of the robot and the system status. Operator can use the HMI to monitor the robot performance, changing, setting, and troubleshooting, and the issues that arises. So, in case in an automated production environment, the PLC acts as the center controller, coordinator of coordinating the operation of the robot and other machinery. It sends command to the robot, receives feedback, synchronizing robot tasks with the other processes, ensures safety and monitor system performance. It also, PLC also ensures that the entire production line work efficiently and seamlessly with the robot performing its task precisely and in the scheduled time. That's all.
Okay, so what is the role of AI and machine learning in enhancing robotics and automation system in electronics manufacturing?
Yeah, like I've already told that the uh, role of AI is very important when it comes for the industrial automation within the robotics. Role of AI is very important, and machine vision is the part of that. So, like you see here in the screen in the background, there is a PCB inspection using the AI camera. You can see here. So using the AI and the computer vision, it is detecting in the real time the whole PCB, analyzing the whole PCB in the real time. So it is all done by the AI model, machine learning model running in the robotics and using the AI, it can able to detect the all the biggest component like the capacitor, the power supply, the ICs, and the voltage regulator, and its soldering condition, whether it's soldered correctly or not, and the placement of all these components are correct or not. Is there is a defect in that? So all these things are analyzed and done in the real time and very fast speed using the AI. So it's a very important part for any kind of robotics automation or industrial automation, that this AI helps you in analyzing the data in the real time. Using the AI, you can analyze the defects in the soldering. You can analyze the defect in any kind of any kind of scratches and visual defects on in this PCB in real time, and it can also analyze the missing components from the whole PCB in the real time. Like you can see, it can detect the capacitor, power supply, and there is no register out there. So it can detect that there is no register in the PCB, so it is not being soldered, or it is not done by the SMT. So it can be automatically being analyzed and then sorted out as a defective manufactured product, and been sorted out by the robot automatically. So this is the how important the AI is in the any kind of industrial automation or in the PCB assembly line or anywhere. They helps you in analyzing this. In same goes for the instead of using this image, this visual image, the color image, you can use the thermal camera to detect the thermal stability and instability and thermal throttling, and use the AI to determine the thermal throttling in the PCB and analyze the PCB in the industrial manufacturing, and sort out the components that are more vulnerable and more that cause more defect, more that might got affected when the exposure to heat. So all these things can be done in the real time and with using the AI, and this is how the machine vision and the machine learning models are being trained to identify these kind of capacitors and these ICs, and they can classify these capacitor, IC register, and and automatically detect on the PC line like this. You can see in the real time. It's all happening. It's a whole assembly line picture, and it's all happening in the real time. It is being analyzed by the camera using the AI in the real time, and then it sort out the data that the power regulator is there, the capacitor is there out there in the result. You can see here in the result section. In the result section, it's already there. So this is how important the AI and machine learning when it comes to the comes to the automated robots or any kind of industrial automation system, where either the assembly line inspection system, test and measurement, or the PCB assembly, whatever there is. This is how the AI and machine learning comes to in the role, and it helps in those robotics to make them automate. Actually, they are actually what these robots are. They are just a hand with some motors and mechanical parts. They are not intelligent. What gives them the intelligence is the AI and the machine vision. So if you automate anything, you need the intelligence, the human brain, and that human brain is the AI. And these mechanical parts are just a part of that AI that being combined to work together and make a whole ecosystem automation.
Okay, so what programming languages are commonly used to program robots in electronics industry?
Actually, in the electronics industry, several programming languages are commonly used to program the robots depending on the type of the robot and its specific requirement. Some of the most popular language which are available are the first C and C++. This is very important language, and these are widely used due to their efficiency and the control over hardware. Many embedded systems and the robot control systems rely on the C or C++ for tasks that require real-time performance and the low-level hardware access. Another language is the Python. It is which is also known for its simplicity and the readability. Python is often used for higher level programming and prototyping. It's popular in the robotic research and for application involving machine learning and the AI. Another language is the Java. Although less common for the low-level control, Java is used in the application that requires portability, especially in mobile or industrial robots. Another language is a robot operating system, normally known as ROS. While not a language itself, ROS is a collection of tools and libraries that supports robot programming. It is often used with the C++ and Python to develop complex robotic systems, particularly for the research and the development. Another popular language is the MATLAB and the Simulink. These are the robotic for the simulation modeling and control systems designed particularly in academic and the industrial research setting. Next language is the LabVIEW. It is known for its graphical programming environment. LabVIEW is often used in industrial automation and robotics for tasks like data acquisition and the controlling robotic system. Another language used in this one is the VHDL or Verilog. These hardware descriptions languages are used in programmable logic base, yani PLDs, are field programming gate arrays, FPGAs, which are sometimes used in the robotic controls. These are the main languages which I described. That's all.
Okay, so how do robots contribute to quality control in electronics manufacturing?
Yeah. So in the electronics industry or manufacturing or assembly, they are not being only being used in what's the sorting out the equipment or analyzing or diagnostics the PCB or PCB or doing the assembly and doing all those kind of sorting automatically. They are being not only limited to that. We can also now being using in automatic quality control system and inspection system for using the robot. So like one of the example that you can see here in the background here in the screen. 1 minute here on the screen. these things. So here you can see here, this is the real-time video of one of the quality control system that we have designed here. So what it is doing, it is inspecting out the scratches in the whole in the whole PCB or in the whole devices, and it can automatically identify those scratches, that these are the scratches are there on the PCB that might be not good for the quality, and it is not up to that quality that we need for the for the consumer. So it using the AI and the real-time video, it can analyze the scratches and the manual defect or the holes out there or the dents out there on the PCB, or any kind of or the case or whatever the things is that it is doing it in real time. It is detecting all these scratches. All these green boxes that you have seen are the scratches, and the yellow boxes that is detected are the holes or dents that are on the PCB in the real time. And all this data is being sent to the robot here in the real time, and at analyzing those things and inspect and helping us in that is being that take a lot. If the same job can be done by the human, but it take lots of time to the eye inspection, a very detailed eye inspection, but which using this AI and machine vision, they can do the very detailed inspection of manner, scratches, the holes, the dents on the body or the PCB or any kind of other defects, and they can analyze those and helps in maintaining the quality of overall product, that the product should not there we can set threshold that there are certain 5 to 6 number of scratches and 1 to 2 number of dents are negligible, and we can have that. But above that threshold, if there is more scratches and dents, then it might not be good quality, and it will not be good for the for sending out to the customer. So this is how they can help in analyzing those defects, scratches, and the dents, and helps us in controlling the overall quality of whole manufacturing systems. So this is how they can help in us also in the manufacturing and the quality control system.
Okay, so what role does IoT play in automation systems in electronics production?
Yeah, this is the one of the great question that, yeah, it's really interesting question. So here currently everything now we have done that we have seen that these robots have the camera and they're analyzing the image, sorting out the PCB defective items, or doing the automated assembly, doing the automated system. All these things are being in closed loop, or being done directly in the whole production line. But there is no way where we are using the IoT in all these scenarios. So where the IoT comes and how this plays role in the electronic manufacturing and productions. So suppose that we are what's it we have certain number of productions lines there in the particular industry, like we have certain small units, that this unit can handle the 100 phone screen inspection, and this unit can handle the maintain the 100 phone inspection system, and then we have another unit that can maintain the 100 unit production system. And then we need to monitor them, all of them together, of which unit is performing it and how much, and what is the environment condition that is being needed for that production, that for particular testing or particular inspection. Like suppose that if you go for the semiconductor industry or semiconductor production, then there is a particular conditions out there that the air quality should be below that, there is no dust particle, the temperature should be maintained to the particular. So for any kind of production and assembly, there are certain requirements, environment, right? So how do we maintain that? How do we maintain and ensure that those particular units who are doing this kind of automations, who are doing that kind of automations, are achieving and they are in particular environment, then we can add those sensors to identify the environmental condition, the air quality, the dust particle inside the production line, the noise condition, the vibrations, all those we can implement those sensors in those particular small units, and then we can send those data to the dashboard where we can monitor all those environmental condition, and we can maintain the environmental condition that is needed for. So here the comes here the AI, here the IoT roles comes. These sensors are sending the data using the internet to the to the person to maintain particular environmental condition, to maintain the air quality condition for the semiconductor. There is no dust, maintaining all those things, monitoring them out. And second thing, there is another thing is called digital twin in IoT. So using the digital twin, we can actually replicate. So there are lots of big, motors and big robots are there in the industry. So if we can use the IoT and digital tune to monitor those robots movement and all those things in the real time, so that we can, before they get into the into some kind of defect, or they can, before they can go into the faulty condition, we can predict that this robot might not be working perfectly and it need maintenance before doing the particular automation, so the whole production line didn't get a stop. We can predict it out. So here the digital twin and IoT comes in the role. So there are lots of small areas like monitoring the data, monitoring the environmental condition, monitoring the temperature of the system or environmental condition in the production environment, or predicting out the doing the digital tune IoT and digital tune digital tune IoT, using the IoT and predicting out and do the predictive maintenance of this automated automation system, the robotics arms. We need the IoT, and here how these IoT roles came in play in those all industrial automations.
Okay, so my last question for the session. How does Industry 4.0 affect robotics and automation and electronics industry?
So now the technology is going very advanced, and still we are using the human in very areas, and we are still dependent on cobots that are being that are being instructed, that take instruction from the human. Still there are lots of human being used. So using the using the while we are going towards the revolution, and we are going towards the industry 4.0. So now we have the very fast network connectivity. Now we have very smart AI models, and very now we have also generated the generative AI systems. So all these things are going to revolutionize, and this going to change the things that we are using till now. Like with the implementation of the 5G technology, one can control the robot from some other countries in other continent. Till now it is not these things cannot be implemented, and not possible because of the slow data rate and the bandwidth. Now the revolution of the 5G and the 6G, the 7G, all these revolution and extent of the bandwidth and the speed of internet, we can control, and we can do the jobs from one continent to the other continent. So the whole production line, the whole camera inspection system are there in the other continent, one part of the world, and then that is being monitored and done by the engineers living in the other part of the world. So all this can be done in the industry 4.0. All this can be possible in the industry 4.0. And using the generative AI, now they can do more, they can generate out their own designs, and they can generate all the solutions to the particular problem using the generative AI. So they can also be used in the industrial 4.0, and they can revolutionize the whole things. Like currently we need the human, like, so there are the certain kind of problems we are facing in the industry, like suppose the detecting, like this one, the detecting scratch and defect, we are facing certain kind of problems, and we humans need to be analyze those problem and found the solution ourselves. Now with the help of the generative AI things, the AI itself can give you the solution. So okay, this is the problem, okay, now let me think, and the AI think itself and then give you the solution. So AI will find the problem, AI will give you the solution as well using the generative AI. So this is all the new revolution of the industry 4.0. Hello?
Yes, sorry. Okay, so thanks for sharing such insights with us. And if you have any question, you can post it on the comment section of our live session. We will address that question in our next live session. Thank you.